We just finished up the first warm-up question, right? We did two sum, kind of a classic interview question. So you did pretty well with that one. You got to the most optimal solution pretty quickly, and you came up with three solutions actually, which was really good. So now I got another question for you. I just pasted it in there. So why don't you just take a look at that, and let me know if you have any questions.
In an array A of size 2n, there are n plus 1 unique elements, just over half. And exactly one of these elements is repeated n times. So, okay. So there are n elements that are repeated once, and one element that is n times, for a total of 2n elements. Okay. Return the element repeated n times. That's the element. So I'm giving in this input list, and again, I guess I want to have, if I have an input like 1, 10, 2, 1, I want to return 1.
Right.
So, yeah, so this could definitely be done in one pass, obviously. It's not going to be more of O of n. I guess it's just how to store it and how to do it as quickly as possible.
Okay.
I guess I can code out the naive solution.
Sure.
Right away. I can have like a list of already seen stuff. And then loop through this thing. This time I don't have to use the index. I can use the actual thing.
Right.
The actual element, because there's nothing with indices. So for num, if num in already seen, if we've already seen it, then hey, it must be the thing that's repeated. So therefore, we can just return it. Otherwise, we need to add it to append it into already seen. Okay. And then, yeah. And I guess we're guaranteed to have this return if our input conditions are that.
Yeah.
Okay.
Okay, so then let's just run through the time and space complexity of this solution that you have here.
So the time, I guess the worst case scenario is that the first n plus 1 elements in order are all unique, and then it's like the n plus second one where I finally see, haha, there's the duplicate. That's like the latter half, it's all the same number. So that means it would take, at worst, n over 2, which is just n, O of n. And then the space, again, that worst case scenario is I would be storing, oh, actually, that's not n over 2, because the length is 2n. That's literally O of n, okay. O of 2n over 2.
Yeah, I mean, you can assume that 2n is actually
here. I mean, yeah, it all drops out. But,
right.
And then the space here is obviously O of n as well. Because, yeah, worst case scenario is that.
Yeah. So time complexity you're saying is O of n there?
Yeah, that'd be the worst case. I guess the average case would be different.
So it looks like you're storing this already seen as an array or a list, right?
Yeah.
So what's the lookup? What about line 14?
Oh, true. Okay, so we have to search through the entire thing. That's O of n as well. So I guess this is O of n squared. No.
And why is that?
Yeah, or certainly the worst case is O of n squared, because we have the for loop, but this if statement here, this check, is going to also be O of n operation. Right.
So this is kind of like one of the things with Python where you may not realize it, but that in operator in that case is going to cost you O of n because you are looping through the list there. Okay. So moving on, just with this solution here, actually, is there a way to get the time down to O of n just with a quick little change?
Yeah, because this feels really efficient. Like I started off by saying it should definitely be one pass O of n.
Right. So that was your original thought. So how can you do that with this solution here? It shouldn't be too much extra work for you.
Maybe instead of adding something, do I have to remove it, or what? Oh, okay. I could just change it to a hash map.
Sure.
I literally, to change the lookup time to constant. I literally don't have to store anything. I can just, instead of appending, I could put in, add it to, make it num equals 0 equals hello world.
Sure. Yeah, that's it. In this case, it actually might make more sense to just use a set.
Okay.
But that's pretty much what you're doing by saying that the value doesn't matter. So
how does that work in Python?
You can just make this into a set like this, and then you can add it as you go, like you were already seen. .append I think works with sets. I could be wrong, but this way you get that O of 1 lookup.
Gotcha.
So in this case, like you said, it would, like your original thought, right? You get O of n. So just that quick change in data structure really changes the runtime there.
Nice.
Okay, so now we're down to, if you can update for me. So now we're down to a time of O of n, space of O of n. Can you think, this is a little bit of a challenge now. You got to the good solution pretty well. So I think that there's a way to do this with less space. But let's say, I'll give you a hint that it's constant space, and we can maintain the runtime of O of n.
Okay. So yeah, this does seem a little weird. We're clearly storing lots of things we don't need, because we only need the one answer, the one result, and yet we could be storing up to n unique things here. So there's clearly an inefficiency. It's just how to eliminate that is the question, I guess. So we determine if it's duplicated by if we've seen it before, or if it exists in the future, or what if, I wonder if you can like have an accumulator or something so that we're constant. Like let's say what if we added or multiplied all the numbers together, or some sort, accumulator that the n we can get back from that number. Like I'm thinking like greatest common divisor. If all these numbers were prime, that would be an easy thing to do if we just like multiplied them all together. It feels like there'd be a way to amalgamate them.
You could have something like this though,
Yeah. No, I mean, clearly.
So I don't know if that'll work. You're kind of on the right track in thinking of a little more math oriented. So I think this example that you put on line 6, I think that might help you. I'll give you a little nudge. I think that's actually a perfect example to see a really interesting way to go about this one.
So on that 1, I go to 10, I go to 2. So, okay, so 3/4 of the way through, I still don't know the answer. When I'm going through n plus 1 unique elements, I don't know the answer. And then it's on the n plus second thing that I do know the answer. How can I get that out? I'm still thinking like math of like an accumulator I can do, some sort of operation I can keep applying as I go across it.
I wouldn't focus on any arithmetic operations or anything like that. I think I don't want to give you too many hints. So why don't you just look at line 6 there? I think that's going to be, just look at it as a whole rather than an order n. Look at the actual input itself, and what do you know? What are you returning based on what you know, just from just looking at it, not even worrying about the code. And actually, you know what? I'll give you one more example just to kind of make this a little bit easier. And then, sorry, I'm not used to. And then I think this will be 1, I believe. Is that a valid one? 1, 2, 3.
No, you're missing 1, 1.
Oh yeah, sorry. So yes, that is exactly what I wanted. So Why don't you take a look at that one? It's a very specific example.
Very specific.
And then see if you can find there's a pattern. I think is another hint I'll give you.
So what if you don't look at every single thing? No, that'd be helping time complexity, not space. And still, that'd just be some pattern. Oh, wait a minute. Do they necessarily have to be the same thing twice in a row, always? Yeah, wait a minute. If you treat this as like a circular buffer.
Okay.
I
don't know if that'll be.
No. Okay, but wait, within the past two, there's always going to have to. Like the worst case, if I copy this thing on line 6, if I had instead it's like a 1 and then a 2. If I'm ever at one index, let's say I'm on the 3rd index there and I'm looking at the past 2 ones, there always has to be some point where I'm looking at a matching value.
Okay, I think that's on the right track. Yeah, why don't we start coding it up? I think you're going to get it. I think you may have it. I may just be misunderstanding you. So why don't we just start writing this up?
My func 2, yeah. Input list. Okay, so I want to have for num in, or now I want the actual index for I in input list in range lang of input list. Okay. So, in Python, -1 works, right? Yeah. Okay, actually, so now I want to do 1 comma that. I don't want to start at the 0th element. I want to start at the 1st. So I want to say if I is the same, I want to say input list of I is the same as the I minus 1 if it's the previous one, or it is the same as the 1, 2 previously. I think mathematically that's going to work out too, because it's half of every single one. There's always going to be a pattern like that within the entire thing.
Okay, look at the example on line 10. See if that holds.
Line 10, yeah. The very last index. Oh, and the very first one. Well, I guess the very first one we're not looking at in this case.
I see. Yeah. Okay.
Yeah. Wait. In Python like I know that if I would do input list of -1, it would give me the last element in the thing. Does that work as well for -2?
Yep. Yeah. It starts at -1 in the back and then counts down as you go left.
Okay. Cool. So I can actually start this at 0. There's no need to edge check like that. Okay. So yeah, the very first one, it would see that, hey, that thing at the end is the same as it, treating it as like a.
And what about on let's run through line 6.
Line 6. Yeah, again, at the first and last, or just the first one looking back would compare to 1 and 2 and see that it's the same.
I'm not following you there.
So right, for line 6, if for the very first iteration of this for loop, where I is 0, if I of 0 is equivalent to 0 minus 1 of input list, in this case that's the last element of the list, which is also 1. So this would trigger this if statement. Then we can return input list of I.
Okay. Based on that logic, let me see if I can. I don't think that the conditional on 27 is going to work with the negative indexing the way that you expect. Let me see if I can think of an example here. So yeah, so if you have So you're having the circular portion in your head, right? That's kind of what you're going with here.
Yeah.
Okay.
Yeah, the negatives definitely work on the term, or you already said that.
Right.
But yeah, I guess the Python's negatives make it much easier than the other languages to have like a circular buffer idea.
To be honest, I've actually never indexed something like this where you kind of run back from 0. I'm not sure if this would work 100%.
I just tried in the terminal. I think it.
But I totally see your logic, so I think this is actually a little more creative. Let's assume that that's how the indexing can work, and you're kind of taking the circular.
Yeah, if I were coding in a language that didn't have this feature, then I would just have to have more complicated logic to not segfault.
But yeah, no, that's actually a really clever way to go about that. Let's assume, again, I'm not sure, we can't compile it right now, so let's assume that that works. That's actually really, really interesting. I never thought to do that. The way that I was thinking was, if you notice here actually, before we get into that, so what's going to be the time and space of this? You don't even have to write it. You can just talk about it.
Yeah, space is obviously constant. I'm not creating any new structures. Time as well, we're YOLOing it. It's kind of whatever, O of n, one path.
Right. So sort of the reason why I said this would be a great example is I was assuming, or I was going kind of hinting at a sliding window of 4. And in any window of 4 in all of these examples here, there will be an element. The element that you want to return will be so basically 4 in every 4 there will be 2 of your element no matter what.
Okay, so I use the sliding window size of 3 constant.
Right, and I'm trying to see if the 3 is valid. I don't.
When you said for line 6, when you said a sliding window of size, was that hard coded? Was that because the length was 4, or? No, you were just thinking it was 4. I guess 3 would.
Sorry, what was I missed to the first part? I think you cut out there.
When you said sliding window size of 4.
Yeah. So take this for example, right? You could do basically a nested for loop with this, and then this would return true, meaning it would return 1. But let's assume it doesn't, and then you just shift it over 1, and you'd walk through the array 1 time for O of n, and you just check this window for a duplicate.
Yep, exactly.
So that is what you're doing.
So because of the wrapping around, you can actually do it with a sliding window size of 1 less.
Right. So the wraparound is interesting. It might be unique. And again, I'm not 1,000% sure that this is going to work valid. It might. The logic that we're talking through is good, and this is definitely a solution that I did not think of. For Python
I think it's the same solution, just a different element. I didn't formalize it out as a sliding window approach, which
exactly, yeah. No, yeah. Really
if I didn't think of it as a sliding window problem, then I could have probably gotten it quicker and expressed my answer better.
Sure. Yeah. No. Overall, though, really good job. So yeah, do you have any questions? I can give you a little bit of feedback if you want.
Yeah, sure.
So yeah, I know we talked about it during the last question, but you did a good job. I think I kind of chose this after seeing or providing the feedback last time that it's good to kind of have examples at the top. So like having this example here as being on this side of it, I was able to directly point to it. And, you ended up coming up with basically a better solution than mine. But, it's always good to just write stuff out because we can work through stuff and visualize, even though we're not in front of a whiteboard together, right? So good job. The only little tiny thing I would say is just name your functions a little more descriptive if you can. It depends on who's interviewing you, obviously. Of course, because I pasted the question and I know what I'm asking. But some people might want to see if you can give descriptive, variable names, names. And
especially if I'm using a helper or something to differentiate between them.
And another really small thing is that technically it did say that the array would be called A, but it does not matter. I think we were definitely together throughout this, so you did a good job kind of bringing me with you. So yeah, good job.
Okay, cool.